This is our second lesson from chapter 15. Still looking at second derivatives and possibly even further. And actually our first question, we're going to look at higher derivatives. What happens if we go beyond the first derivative and the second derivative? So I've started off with an equation and I'm just going to differentiate it. So dy by dx, bring the power to the front, decrease the power by 1. Do that for each of the terms. So for 7x, remember that's just going to be the number. Derivative of any number is just going to disappear. Also remember, if this question would have started with f of x equals, then our first derivative we just put f dash of x, or f prime of x if you're doing AP. We can differentiate again, as you know, the second derivative, d2y over dx2, power to the front, decrease the power by 1. And if we're using the dash notation, we could put f double dash of x. And that's as far as we've got. Now, when we're doing things like physics, and some of you might be doing AICE physics later, this could be an example of an equation that's displacement. Displacement is very similar to distance. If you differentiate that, that actually gives you velocity, which is very similar to speed. And if you differentiate velocity, it actually tells you what acceleration is. And actually, you can go beyond that to find other things as well. So if we want to carry on differentiating, we're just going to, instead of putting 2, we're going to put 3 to show that we've differentiated a third time. But using the same rules, bring the power to the front, decrease the power by 1, and so on. Once again, derivative of 6 disappears, and I can carry on a little bit further still if I want to. I can do a fourth derivative. Now notice on this side though, I had f double dash of x, and I have f triple dash of x. Once we get past 3, it gets a little confusing with all the dashes, so we just actually put the number to show which derivative it is. So this is the fourth derivative here. And we could carry on. We could do the fifth derivative. Notice it's just a 5 this time. And we could even do a sixth derivative, and it's 0. And if I was to write this one out, then this would be f6 of x. And if we were to carry on, then the derivative of 0 is just 0. And if you're curious, we could actually have a little geeky badge there as well. Find out what the third derivative of y is with respect to x. Now we've got one question we're going to look at here. We're going to extend this a little bit further. We're going to link in our chain rule that we learned in chapter 12 as well. So we're going to find out the maximum minimums for this question. So first of all, we really need to rewrite this equation. We want it as x to some power to make this a lot easier for us. So when we differentiate this and bring the power to the front, decrease the power by 1, so a half x to the negative a half. Now this one here, we've got our parentheses. This is going to be our chain rule. So we're going to bring our power to the front. We're going to decrease the power by 1, but we also have to, importantly, remember to times by the derivative of what's inside the parentheses. So we're also going to need to times by negative 5. And then if we simplify this, negative 5 times by a half is negative 5 over 2, and therefore we could write it like that. And we're going to set that equal to 0 in a second, but we're also going to need that second derivative as well. So we might as well work out that second derivative at the same time. So if we differentiate this, bring the negative half to the front, decrease the power by 1, negative a half times a half is negative 1/4. And negative a half take away 1 is negative 3 over 2. When we're doing this one, remember to do the chain rule again, bring the power to the front and multiply. 2 negatives make a positive, 5 over 2 times 1 over 2 is going to give me 5 over 4. Decrease the power by 1, but once again remember to times by the derivative of what's inside the parentheses here, which is negative 5. 5 over 4 times negative 5 is going to give me negative 25 over 4. Once again, decrease the power by 1. So, we're going to set this equal to 0, then we're going to go ahead and solve to find out what our maximums and minimums are. Get into good habits, tell the examiner exactly what we're going to do. Maximum and minimums occur when our first derivative is 0. And now we're trying to solve this. It's actually much nicer if we transform it back to what the original question looked like with the radicals or the square roots in there. So x to the negative a half, square root of x on the bottom. 30 minus 5x to the negative a half, same thing. Square root of 30 minus 5x, but on the bottom. And we can solve this by cross multiplying, because then that gets rid of our fraction rather nicely. Also, I can see that both of these have a 2 in here as well, so we can divide both sides by 2. 1 times 2 is just 2, so that could all cancel too. And then we've got something much nicer to solve. Not too nice because we've got 2 square roots, so perhaps if we square both sides, that'll take care of that. When we do that though, it's going to be very important at the end of the question to substitute back to make sure that we don't have any extraneous solutions. But now you can see this is going to solve fairly easily. X equals 1. Now we need to go back to the original equation now to find out what the y value is. So square root of 1 plus 30 minus 5 times 1, that's 25. Square root of 25, 5, 1 plus 5 is 6. So we found our x value, we've also found our y value by substituting in. We now need to find out if it's a maximum or a minimum. So we're going to go ahead and plug this into our second derivative. And if you've got a good calculator, you should be able to work this one out relatively easy. You actually end up with negative 3 over 10. This one's less than 0, so this means that it's actually going to be a maximum. If it had turned out that the second derivative was 0, like we had in the previous lesson, then what you'd do is you'd find the slope at perhaps 0.9, find the slope at 1.1, and then use those rules from last time to actually determine whether it's a maximum or a minimum. And you're probably going to get something like that in your exercise as well today.